Welcome to Robo's Physics Adventures. Today Robo will be learning about one-dimensional vectors and how they relate to position and displacement. Robo is working with Jordan and Graham today. The motion diagram of the portion of the run for a Canadian athlete during the Ironman triathlon was provided to them. Mr. S said that geometrically we show a change in position using a vector. An arrow symbolizes a vector. The tail of the arrow is the initial position or sometimes the reference point, and the head of the arrow is the final position. The change in position from positions 2 to 4 will have the tail on position 2 and the head on position 4. Note that the change in position from 2 to 4 is the same as the change in position from 2 to 3 plus the change in position from 3 to 4. The vectors here show that the runner is moving in the east direction. Therefore, the change in position from 2 to 3 is 5 meters east, and the change in position from 3 to 4 is 9 meters east, giving a total displacement from 2 to 4 as 14 meters in the east direction. When adding vectors geometrically, you will place the tail of the second vector on the head of the first vector. The resultant vector will start from the tail of the first vector and end at the head of the last vector. Mr. S continued on by looking at another example. Here the change in position from 1 to 2 is 8 meters in the east direction. We can also look at the change in position from position 2 to position 1. This means if the starting position was 2 and the end position was 1, the runner would have ran 8 meters in the west direction. Note that if east is defined as our positive sign convention, then the change in position from 1 to 2 is positive 8 meters in the east direction, and the change in position from 2 to 1 is negative 8 meters in the east direction, or alternatively 8 meters in the opposite direction of east. We could also change our sign convention and take west to be positive. If west is positive, then the change in position from 2 to 1 is positive 8 meters, and the change in position from 1 to 2 is negative 8 meters in the west direction. Note that 8 meters east is equivalent to negative 8 meters west, and 8 meters west is equivalent to negative 8 meters east. The negative sign simply means the direction is opposite. In order to add two vectors algebraically, their direction should be the same. For example, 7 meters east and 4 meters east can be added directly to 11 meters east because they're both in the same direction. But when you add 7 meters east to 4 meters west, you should either change both directions to east or both of them to west. If you change the sign to east, you will have 7 meters east plus negative 4 meters east, which will equal to 3 meters east. This also equals to negative 3 meters in the west direction. If you were to use west as your positive sign convention, you will have negative 7 meters west plus 4 meters west, which will equal to negative 3 meters west or 3 meters east. Note that both methods will get you consistent results. To save time and to avoid writing all the signs in the equation, we can write our sign convention and use positive values for vectors that correspond to the sign convention and negative values for those that are opposite to the sign convention. For example, if we take east to be positive for our sign convention, then we will have positive 7 because it's in the east direction and negative 4 because it's in the west direction. Our final answer will be in the direction in which we defined our sign convention. If we took west to be positive, then we have to use negative 7 because it's in the east direction and positive 4 because it is in the west direction. Our final answer will be negative 3 meters in the west direction or positive 3 in the east direction. Mr. S gave the group an example to look at. He said that there is a student that walks from position 1, their home, to position 2, the running track. Then they travel from the running track to position 3, the store. What is the total change in their position? Jordan looks at the problem geometrically. He says that the student travels east first from position 1 to 2, and then west from positions 2 to 3. We would take the tail of the second vector and place it at the head of the first vector to add them. The final or resultant vector will start from the tail of the initial vector and end at the head of the final vector. Graham said that the change in position from 1 to 3 will equal to the change in position from 1 to 2 plus the change in position from 2 to 3. If we take east to be positive, then the change in position from 1 to 2 will be positive 500, and the change in position from 2 to 3 will be negative 180. The addition will result in 320 meters east. Mr. S then said the distance doesn't consider the direction that the object travels. The distance focuses on how much ground the object covers. Since the distance has no direction, distance from position 1 to 2 is 500, and the distance from position 2 to 3 is 180 meters, for a total distance between positions 1 to 3 of 680 meters. Mr. S said to subtract vectors geometrically, you can add its negative. Imagine subtracting the change in position from 1 to 2 by the change in position from 2 to 3. We can rewrite this as the change in displacement from 1 to 2 plus the negative of the change in position from 2 to 3. This would mean that we can add the negative of the second vector to the first vector. By taking a negative vector, we switch its direction to the opposite direction. To add, we then take the tail of the second vector and place it on the head of the first. The resultant vector will start from the tail of the first vector and end at the head of the second vector. Note that when the starting position of our vector is the reference point, we don't need to include the change or the delta sign because the reference point here automatically has a position of 0. As discussed previously, we can algebraically determine the change in position from 2 to 3 by subtracting the position vector 3 by position vector 2. Geometrically, we can do the same by taking position vector 3 and subtracting it by position vector 2, and we can see that the result is a vector that represents the change in position from 2 to 3. Mr. S then posed a problem. Jordan is walking his cat from home to Park A, which is 300 meters to the east. Then he sees a dog and moves to Park B, which is 1,000 meters west. After this, Jordan walks 200 meters east to the pet store. Taking home as the reference, determine positions 1, 2, 3, and 4. Then determine the change in position from home to Park A to Park B, and Park B to the pet store. Finally, determine the total displacement and distance. Graham started the problem for the group. Since home was the reference point, position 1 or the home is 0 meters away from the reference point. Park A or position 2 was 300 meters away from home in the east direction. Park B or position 3 was 1,000 meters minus 300 meters or 700 meters to the west, or negative 700 meters to the east of the reference point. Finally, the pet store or position 4 was 1,000 minus 200 minus 300 or 500 meters west of the reference point. This could also be written as negative 500 meters east. Jordan already knew all the displacements from the vectors, but he decided to subtract the positions to make sure that they are consistent. Displacement or change in position from 1 to 2 was calculated by position 2 minus position 1. This was 300 meters east. Displacement from 2 to 3 was position 3 minus position 2. This yielded negative 1000 meters east. Finally, displacement from position 3 to 4 was position 4 minus position 3. This was calculated as 200 meters east. Robo looked at the total displacement as the change in position from 1 to 2, meaning from the initial point to the very end. It added all individual displacements to get negative 500 meters east. Robo then tried using the alternative position method and subtracted the final position 4 by the initial position 1 to get the same consistent answer of negative 500 meters east or 500 meters west. Robo then calculated the total distance by adding all the distances traveled in the different intervals to get 1500 meters for the total distance. Today, Robo has learned about one-dimensional vectors, how they have size and direction, how they are added and subtracted algebraically and geometrically. Robo has learned about negative vectors and the applications of how math can be used to solve physics problems. Robo will have to do some review in order for its circuit to store these concepts into its memory. Robo is looking forward to the next physics adventure.